Section 9.3.9. A simple random sample of size n is drawn from a population that is known to be normally distributed. The sample variance is determined to be 10. We want to complete parts A through C. So we're going to construct a 90% confidence interval for the population variance if the sample size n is 20. Okay, so the first thing we need to do is we need to find what are degrees of freedom. So if we want to find our degrees of freedom, it's going to be n minus 1. And so therefore n is 20, and when we subtract 1, we get 19. Okay, so the first thing we're going to do is we're going to look for the lower bound. Okay, so in order to find the lower bound, we need to find this critical value here. So the first thing we need to do is find alpha. And we know that alpha is going to equal 100% minus 90%, which gives us 10%, which gives us 0.10. And then we're going to take that alpha and divide it by 2. So therefore, that 0.10 divided by 2 gives us 0.05. So if we want to find the lower bound, we want to find the lower bound that's a critical value that has an area of 0.05 with the degrees of freedom of 19. Okay, so we can use the table or we can use StatCrunch. Now, I've shown how to do the calculator prior to that, but my recommendation is using the table or StatCrunch. So let's go down here. We're looking for degrees of freedom of 19 and an area of 0.05. So let's go ahead. Here we get 19 and an area of 0.05. So here we get a critical value of chi-squared to be 30.144. So therefore, this is going to be 30.144. Okay, so let's just see how we did this on StatCrunch. We know our degrees of freedom is going to be 19. Okay, and we want this area that we have, which is 0.05. So 0.05. Okay, and that means we want the area to the right here. So therefore, this is the right critical value, and we get 30.144. Okay, so now let's find the lower bound. Okay, so what do we need to know for the lower bound? Well, we know that the sample size n is 20. We know that our sample variance for the problem that's been given up here is 10. And we know that our critical value of 0.05 is equal to 30.144. So now we're going to plug it into our formula. So to find the lower bound, that's going to equal 20 minus 1 times 10 divided by the critical value of 30.144. And therefore, our lower bound, rounded to 2 decimal places, is going to be 6.3. Okay, and so now what we're going to do is now we're going to find the upper bound. Okay, so we already know that the degrees of freedom is equal to 19. Okay, we already know that alpha divided by 2 is equal to 0.05. And so what we want to do is we want to find the critical value where it's going to be 1 minus that 0.05, which is the chi-square, and 1 minus 0.05 is 0.95. Okay, so, and then the degrees of freedom, as we stated, is 19. So now we're going to use the table where degrees of freedom is 19 and we're looking for the area of 0.95. So let's go down here. And so now we're going to look for the following. So we have 19 and we're looking for 0.95. And so therefore there is 0.95. And we get the critical chi-square value to be 10.1 10.117. So therefore, that's going to equal 10.117. Now, if we wanted to use StatCrunch, okay, and we're looking for that area, that means we're looking for 0.95. Oops. And then you can see that we get 10.117. Okay, and now we're going to use our formula to find the upper bound. So again, we know that n is equal to 20. We know that the variance is equal to 10. And we know that the chi-square of the area of 0.95 is equal to 10.117. So let's plug it into our formula to find the upper bound. So we get 20 minus 1 times 10 all over the critical value of 10.117, and therefore we get the upper bound to be 18.78. Okay, so now in part B, we want to be able to construct a 90% confidence interval for the population variance if the sample size n is 30, and how does increasing the sample size affect the width of the interval. Okay, so the first thing we want to do is we want to find the degrees of freedom. And recall that the degrees of freedom is taking the value of n, which is the sample size, which is 30 in part B, and subtracting 1, which gives us 29. Okay, and then we're constructing a 90% confidence interval. Well, we did the same thing up here for 90%, so we already know that alpha divided by 2 is 0.05, so we don't have to go through that again. So we know that alpha divided by 2 is equal to 0.05. Okay, so now what we want to do is, if we're looking for the lower bound, we want to find the chi-square critical value that has an area of 0.05, and we know the degrees of freedom is 29. Okay, so let's find out what that critical value is. So down here, we know that we have a critical value of 29. And we're looking for the area of 0.05. So there is the area of 0.05. And so we get the critical value of 42.557. So this represents 42.557. Okay, so now in order for us to find the lower bound, okay, we know the following. We know that n, which is the sample size, is equal to 30. We know that our variance is equal to 10. And we know that the critical value that we just found is 42.557. And now we're going to plug it into our formula. So we have 30 minus 1 times 10 divided by the critical value of 42.557. So the lower bound is going to be approximately 6.81. Okay, now let's go ahead and find the upper bound. So again, we know that our degrees of freedom is 29. We also know that alpha divided by 2 is 0.05. And so now we want to find this critical value. And this critical value is taking 1 and then subtracting 0.05, which gives us the critical value of the area of 0.95. So using the degrees of freedom of 29 in the area of 0.95, we'll come down here on our table. And so we know that we have 29 and we're looking at 0.95. And so there's 0.95. And so the critical value that we get from there is 17.708. And so again, we know that n is equal to 30. We know that the variance is equal to 10. And now we know that the chi-squared of 0.95 is 17.708. Okay, so using our formula, we know that we have 30 minus 1 times the sample variance divided by the critical value of 17.708. And therefore, the upper bound, rounded to 2 decimal places, is 16.38. So, here we have an interval that goes from 6.81 to, you write that, 6.81 to 16.38. And then up here we have an interval that goes from 6.3 to 18.78. Okay, so let me go ahead and copy those two intervals. Okay, and so let's look closely at these intervals. Okay, let's determine the width. Okay, so if we take 18.78 and subtract 6.3, well, that gives us a width of 12.48. And over here, this interval, which is the second interval, gives us a width of, if we take 16.38 and subtract 6.81, then we get the width of 9.57. Okay, so by looking closely and comparing the width of this confidence interval, we notice that the upper bound of the first confidence interval is greater than the upper bound of the second confidence interval. And the lower bound of the first confidence interval is less than the lower bound of the second confidence interval. So therefore, we can see that the width decreases for these two. Okay, next, what we want to do is we want to be able to construct a 98% confidence interval. So let me go ahead and move this table down a little further. So we want to construct a 98% confidence interval for the population variance if the sample size n is 20, and then we're going to compare the results of those obtained in part A, and how does increasing the level of a confidence affect the confidence interval. Okay, so let's go ahead and copy our formula. Alright, so the first thing we want to do is we want to find the degrees of freedom. We know that degrees of freedom is going to be 20 minus 1, which is equal to 19. Okay, and then we got to determine alpha. Well, alpha is going to be 100% minus 98%, which is 2%, which is 0.02. And so therefore, if we take alpha and divide it by 2, which is 0.02 divided by 2, well, that's going to give us 0.01. So the first critical value that we want to find is the chi-square with an area to the right of 0.01, knowing that our degrees of freedom is 19. So let's go ahead and use the table here. So we know our degrees of freedom is 19, and we're looking at the area of 0.01. So let's go ahead and do that. So we have 19, and then we have 0.01. And so we know that the critical value for that is going to be 36.191. So we have 36.191. Okay, so we know that the sample size n is equal to 20. We know that our variance is 10. And we know that the chi-square with an area of 0.01 is equal to 36.191. So now in order to find a lower bound, we're going to take 20 and subtract 1 times the sample variance, and then divide that by 36.191. So therefore, the lower bound is then going to equal, to 2 decimal places, 5.25. Okay. All right, and so again here, we know our degrees of freedom is 19. We know that alpha divided by 2 is equal to 0.01. And then for the upper bound, we're taking chi-square 1 minus 0.01. And 1 minus 0.01 is 0.99. So, using the degrees of freedom of 19 and the area of 0.99, so we have an area of 0.99 and degrees of freedom of 19. Then we can see that we get a critical value of 7.633. So therefore, that's equal to 7.633. So now we're going to find the upper bound, which is n is equal to 20. Our variance is 10. And our chi-square of 0.99 critical value is 76.633. And now let's plug it in. So we have 20 minus 1 times 10 divided by 7.633. And so therefore the upper bound is going to equal 24.89. Okay, so let's take a look at this interval. So in this interval, we have a lower bound of 5.25, and we have an upper bound of 24.89. Okay, so what is the width of this interval? Well, the width of this interval is taken 24.89 and then subtracting 5.25, and that gives us 19.64. Okay, so we're going to compare these results with the one from part A, because this is part A and this is part B. Well, if you look at the width here, this is 12.48. Over here we get a width of 19.64, and we have gone from a 90% to a 98% confidence interval. So, notice again that we can see that the upper bound got higher and the lower bound got lower, which means that the width of the confidence interval increased